So just want to give you guys some context here. This presentation is I'm going to just really strip it down to really basic concepts on what concurrency is and what channels are. And so, you guys are in core. You guys don't need to know anything about the language Go. Yeah, and yeah, let's get started. And if we have time at the end, I think this presentation is going to take 20-30 minutes. But if we have time in the end, I'll open up the questions, and also I can show some live coding. And that part's going to be Go. So folks who just come and stay for the first 30 minutes, don't worry about it. I'll use diagrams and some really basic concepts to help you understand this very important concept we have. Okay, cool. Without further ado, let's start the presentation. So I want to kind of give folks kind of some ideas about what is a channel, what a channel is used for, and how can channels solve concurrency issues, which I will give an example here in a minute. And then some examples. Now the last three is actually have to use code examples, so it won't be included in the slides, but I'm happy to kind of go through those examples in the text editor afterwards if we have time. So yeah, without further ado, let's get started here. Now, what is a channel? A channel is like the basic word channel means like a communications medium, right? You look at this picture, right? Two gophers here, or two animals here using like a telephone with a string, and the pink gopher talks, and the blue gopher hears the message from the other side. And yeah, that's what a channel really is. Now, instead of gophers, you want to think about the gophers or these really cute animals. You want to think about it in terms of runtime, in terms of activities that's running in the program, right? So you can imagine it as a function call, right? And you can say, oh, the pink function calls and sends a message to function B, and there's this concept like concurrency, which I go into a little bit, which is basically, if two functions were to run together, what happens? Why do we need a channel, right? So if any of those terms are confusing, don't worry about it. An example here I'll walk through will kind of give you an idea of what I'm talking about. So yeah, so with channels, right, something really technical like the term channels, you would assume that you need to know about what Go routines is, what concurrency is, what a race condition is, right? Those are really, technical terms. Sure, knowing those terms are really helpful, but in this presentation, I want to make it as simple as possible so that folks don't even need to know about any of those concepts. You just need to know about, a basic example of a real life problem, right? A real life problem that kind of some of us have experienced while we're working with other people. So the example here that I want to give is a website builder, and in this case I use Kajabi as an example because this scenario actually happened to my wife, and when she was working alongside with with a boss, trying to build a website using this website builder. Now, supposedly we have two designers logging into website builders simultaneously, right? And they're both kind of editing the same page. We have designer one on the left, designer two at the right. And they're kind of looking at the same page. Designer one starts editing it, designer one starts first, and then designer two starts later. So both of them are executing activities. And this is where the concept of concurrency comes in, right? You have two designers executing their edits all at the same time. They are different edits, so nobody knows what each other is doing. So if designer one on the left says, well, I want to change the hero section to be, like I want to change, the text to be something like, I want to bold the text. And then the designer two says, oh, I don't want so many text. I want to, cut basically everything out. Maybe just leave like 3 words. But without channels, they have no idea what both of them are doing. So, so what if, okay, and this actually happened in real life, is that designer one decides to save the work first. Designer one says, okay, I'm going to apply this bold formatting to my hero section, the text, whatever. Designer one clicks saves and publish website, goes live, right? And everyone see that the website's already bold. Now, designer two doesn't have any idea that's already happening. And designer two is still like happily, like cutting off text, changing some sections, or changing the buttons, whatever, anything that's not related to what designer one's doing. And yeah, designer two is completely unaware of the situation and keeps on editing it. And designer two might say, oh yeah, hey, why not add another section here, right? Why not add 3 more sections, or spend 2 or 3 hours trying to edit a web page without even knowing that designer one already saved it. Now, in the perfect world, you would expect that this would, this would not be a problem, right? But what actually happened in real life, which actually happened in this case, is that designer two, when they finally decides that, okay, I'm done for the day, I'm putting in all these edits, they look good, they look awesome, let me save my work, and clicks the publish button, and oops, all of the changes are rejected, designer two. And designer two doesn't know what happened, and loses everything. And then designer two will say, hey, what's going on? Where is my, I spent all that 2-3 hours doing all that edits and it's gone now. And then when designer two refreshes the web page, he or she sees that the changes were different, were actually done by someone else. And so designer two like calls up designer one and asks, hey, did you make anything changes to the website and what's going on? And designer one says, yes, I made some changes, a couple hours ago. And then designer two was like, well, you should have told me that because I was doing the same change. And now, when I click save, your changes came first and then it overwritten everything that I did. Now this is a very classic example, and I'm sure like a lot of you are very familiar with this kind of issue. And you would think that, modern web applications would have already solved this problem, but this still actually happens today. So it's still pretty common. So it's something to watch out. Now, yeah, so this is essentially a race condition. Now, of course, I'm oversimplifying a lot of the stuff here. I'm not really going into like, variables, values, data model, how values are read, retrieved, sync locks and all that technical terms. Because I know folks are in course, so I want to keep this as simple as possible. A race condition is basically when, one person doesn't know, or one activity doesn't know about another's activity. And then when another user or another designer in this example tries to update the the same resource, they cannot succeed properly. And this resource in this example is the website, right? So we've seen that the the first designer already updates it, but then the second designer cannot see that change, and makes their own changes. And then when they try to publish it, it's being rejected because they don't have a really good handle of concurrent activities that we've seen just now. Both designers are executing concurrent activities, and both don't have knowledge of each other. And when one tries to update and the other one later, it fails. So this problem presents a very interesting solution, which is channels. Channels can solve problems like this, right? Now, without going into detail on how channels work, because that requires code, and I happily can give some examples later. But for now, like, all you need to know what channels does is, let's go back to this example again. With channels, yeah, this diagram is totally, I just made it up in like a couple of minutes. So apologize for that. Really, really simple kind of basic example here. So if going back to the example, activity 1 and activity 2, they are executing concurrently, right? Designer 1 is doing updating a website at the same time. Designer 2 is also updating at the same time. But if you have a channel in between, then what happens is that when designer 1 puts changes, when designer 1, does, like, let's say, formatting of the text, makes it bold, then activity 1 basically has a communication channel to push that change to the earphone wire here into activity 2, and say that, hey, I made these changes. So activity 2 can choose to make certain decisions based on that, right? Activity 2 can choose to ignore it. Sure, like, they can choose to ignore it and then just let it be. Or activity 2 can actually listen, because now they have a communication channel. Activity 2 can listen and wait. And, if activity 2 chooses to wait, then, designer 2 can't make any changes until activity 1 is finished, right? So this is one use case of channels, is that this is the locking component of channels, is where, if a value is pushing channels, it has the ability to lock certain operations, so that, other activities or other functions couldn't execute until activity 1 has finished. Or activity 2 can receive the same updates that activity 1 has made, and then activity 2 can see those changes live. And so in this case, designer 2 will we'll actually see what changes the designer one makes. And so then it gives reassurance to, designer two, and says, and designer two will actually see like the text changes, in bold, or, something like a message box that says that warning, like someone else is editing this web page. Do you want to refresh the page? That gives some reassurance, and designer two will be happy at the end. And then at the end of the day, there's no miscommunications. Designer two doesn't have to worry about their changes being overridden, because they know that other people are doing updates. So they can also use that same communication channel to really communicate back to the first person and say that, okay, I'm making this update, or removing stuff, please be aware of that. So so that is what essentially why channels are so important. And yeah, and channels are really widely used in the programming language Go. But because it's only gained like popularity in last decade, so it's relatively new concept compared to JavaScript. You have like async await feature. In Ruby you have threads. All of them can sort of like coordinate these kind of things. But channels is really easy to understand once you get a hang of it. Because with these kind of example, with these example, you can you can do a lot. And yeah, we just call these sending a value to a channel, receiving a value from the channel. And yeah, that's basically it. So this ends the first part of the presentation. Now I'm going to stop sharing my screen real quick, and then I'm going to open up an editor here. So here I declare channel C, right? Now I can say, I can print out the value of the channel if I wanted to. And line 9, I'm just I'm just sending the value 1 into the channel. Okay. So I can't actually do this because the channel here is, when I push a value to a channel, it's locked. And basically I have to unlock it by doing this. So this means that I'm receiving the value 1 from the channel itself. Let me try to run this. Okay. So it seems like it's still locked because the channel is not closed. And there's this one caveat with working with channels in Go, is that it handles concurrency. It handles concurrent functions that run concurrently. So if you try to do it in an asynchronous function like this, there's a lot of caveats. So to do this, I actually need to do something like I'll need to start a Go function. I will put it in the Go function. And basically what this does is instead of just pushing values directly in like the main thread, in Ruby there's main method, and in JavaScript there's like main whatever document namespace. In Go there's a similar thing where there's this main thread. So if I push channels into the main thread and, do something, then it gets a little bit tricky because I make sure that the channels it's not blocking. So in this case, I would have to specify a go function. Now the go function is very similar to the example just now where, designer one is executing an activity, in the background itself, and it doesn't really affect the main function. It's just kind of like a background function. And if I click run, it executes, right? And I can do something like this, right? Now, actually, this is will be a more clear example. So now I can assign. Now I can assign the value received from the channel C into I, right? So this is assignment operator, and the arrow operator is basically either sending to a channel on line 10 or receiving a value from a channel. Now this is the part where it's like, I have a telephone and then I have the earpiece, and this part is the hearing piece of the telephone. I'm hearing, I'm receiving a message. I'm receiving a message from C. I'm assigning to the variable I, right? So if I print out I, oops, I need to import. Go tends to be very, very particular about imports. If I print I, then I get the value 1. So this is a very basic example of how to use channels, right? First, we make a channel, and then we execute a concurrent Go routine. Inside the concurrent Go routine, we send the value 1 to the channel. And then outside the Go routine, so irrespective of, we don't wait till this operation completes, we listen from the channel. So we can already listen from the channel without it being sent yet. And then I say print line. I just print out this value. So I can even do this. I think I can. No, I cannot. I cannot receive a channel without sending one. Okay. So this is a basic use case. This is a basic example of channels. Thanks everyone for participating. My name is Gooi, and I'm a software engineer at DigitalOcean. So yeah, thanks again.